today we are going to explore the remainder theorem. So, the remainder theorem states that if a polynomial f of x is divided by x minus k, then the remainder is equal to f of k. So, instead of doing long division, we can simply evaluate the polynomial at k, which provides us a quick way to find the remainder without performing the long division. So let's look at an example. Example number 1. We need to determine the remainder of the polynomial f of x equals to 5x cubed minus 6x squared minus 28x minus 2 when divided by x plus 2, or which is equivalent also to x minus the quantity of negative 2. Then the remainder is found that by evaluating f of k, which is our k, is negative 2, which is we have there f of negative 2. So to find our f of negative 2, we are going to substitute the negative 2 in all variable of x in our polynomial equation, which is this gives us f of negative 2 equals to 5 times negative 2 cubed minus 6 times negative 2 squared minus 28 times negative 2 minus 2. So simplifying this, we will get f of negative 2 equals negative 40 minus 24 plus 56 minus 2. And the result is negative 10. So the remainder, or our remainder of our polynomial equation, is negative 10. So there is another way to find also our remainder, which is what we call synthetic division. So synthetic division is much more easier because it simplifies the process with fewer steps and less writing compared to long division. Just like this figure. As we can see, between the long division and the synthetic division, we can say that synthetic division is more quicker and more efficient method compared to long division, as the long division is more detailed and time-consuming. So let's look at how synthetic division being used in solving or getting our remainder. And this is from the example number 1, which we have the f of x equals to 5x cubed minus 6x squared minus 28x minus 2, which is divided by x plus 2, or our divisor. So we rewrite the divisor x plus 2 as x minus the quantity of negative 2. So we use negative 2 there in our synthetic division setup. And then we write down all the coefficients of our polynomial, which is our coefficients here are 5, negative 6, negative 28, and negative 2. So bring down the first coefficient 5 as is, and then so multiply it by negative 2, our divisor. So after bringing down the coefficient, first coefficient 5, we are going to multiply it to our divisor, which is negative 2, and that will gives us negative 10. And our result, we are going to write under the next coefficient. Our next coefficient is negative 6. So under that, we are going to write our negative 10, the result of multiplying the 5 and the negative 2. So negative 6 plus negative 10 is negative 16. So repeat the process by multiplying negative 16 to our divisor, that will equate as positive 32. And add again negative 28 plus 32, and that will equate to us to 4. And then multiply again, 4 times negative 2 is equal to negative 8. So put the negative 8 under the negative 2. So add the negative 2 and the negative 8, and that will equate us negative 10. So the quotient is 5x squared minus 16x plus 4 with a remainder of negative 10. So this method is quicker and involves fewer calculation compared to traditional long division, making it more efficient choice for dividing polynomials by linear factors. So let's have another example. So in this example, we will find the remainder of the polynomial f of x equals x to the power of 4 plus 4x cubed minus x squared minus 16x minus 4 when divided by x minus 2 by using the two methods, which is the remainder theorem and synthetic division. So first, let's have this remainder theorem. So our value indicator there is k is equal to 2. According to the remainder theorem, the remainder of f of x divided by x minus 2, which is our f of x, will be f of 2. Substitute the 2 in all variable x in our polynomial equations. So that will give us f of 2 equals 2 to the power of 4 plus 4 times 2 cubed minus 2 squared minus 16 times 2 minus 4. By simplifying that, we will get 16 plus 32 minus 4 minus 32 minus 4. And our f of 2 is equal to 8. So our remainder is 8. So let's move on to the use of synthetic division. So by setting up, we are going to use 2 as the value indicator for synthetic division. So we are going to write the coefficients. So our coefficients there are positive 1, positive 4, negative 1, negative 16, and negative 4. So same process, we are going to copy the number 1 and multiply by 2 and add to the next coefficient, which is number 4. So 4 plus 2 is 6. And 6 times the divisor, 6 times 2 is 12. So write the 12 to the next coefficient of 4, which is negative 1. So negative 1 plus positive 12, it will equate as 11. And same as the process, we are going to multiply 11 to the divisor, which is 2. So 11 times 2 is equal 22. So we are going to write the 22 under the negative 16. So adding the negative 16 to 22, that will equate as 6. And 6 times 2, the divisor, will equate as 12. So 12 will be written under the negative 4, and by adding the negative 4 and the 12 will equate as 8. So as we can see, we have the same remainder from the use of remainder theorem method and the use of synthetic division. So overall, the remainder theorem and synthetic division are powerful tools for polynomial division. So the remainder theorem allows for quick evaluation of the remainder by substituting values, while synthetic division offers a streamlined process with fewer calculations. So both of the methods enhance our ability to efficiently handle polynomials, providing flexibility in mathematical problem solving. So thank you and God bless everyone.